You've probably heard it. Glass isn't truly solid, but a slow-moving liquid, which is wild. If that's real, why aren't your windows dripping like syrup or sliding out of their frames right now? In the next minute, we'll dig into the truth, and it's way stranger than the myth. Look at antique windows. The glass often bulges at the bottom. Classic proof, right? Many people say that's because glass has been oozing downward for centuries. It sure looks like it. But if your eyes are telling you that story, what are they missing? But if glass flows, why don't today's windows slump, puddle, or warp? We've built towers of glass that stay perfect for decades. So is the whole glass flows thing actually real? Or is glass breaking the basic rules of solids and liquids? Here's where it gets weird. Solids have their atoms stacked up in neat, repeating grids. Liquids? Total chaos. Atoms slip and slide everywhere. Simple enough. But when you zoom in on glass, it refuses to play by either set of rules. Glass molecules don't form a regular pattern, but they also can't move like in a liquid. They're stuck, forever random. Chaos, frozen solid. So is it a solid or something else hiding in between those two boxes we learn in school? Mindbender. Glass doesn't check solid or liquid on the menu. It's a third category, an amorphous solid. Not quite one, not quite the other. And that in-between state turns out to be the key to how glass is made and why the myth sounds so convincing. When glass is cooled quickly, its molecules freeze mid-chaos before they can snap into a tidy grid. That speed trap locks in disorder. That's why window glass looks smooth but is so unpredictable under the microscope. But does that disorder actually let it creep over time? Now the Mythbuster. Scientists measured 100-year-old glass and skyscrapers, hoping to find any real flow. Nada. No sag. Within the limits of our best instruments, modern glass just stays put decade after decade. So why all the chunky bottoms? Old glass was handmade, wavy, lumpy, and thicker on one side. Builders simply installed the heavy side down, not because it drooped, but to keep the window stable. The sag you see was baked in on day one. But what if glass really did flow at room temperature? Get this, it'd take longer than the age of the universe for your window to even start to sag. On human timescales, your house, your city, even your species would be gone long before the glass budged. Technically, some physicists call glass a supercooled liquid. Its molecules frozen out of order instead of crystallizing. Others insist it's a solid. Either way, in any human lifetime, glass acts rock solid. So why is it still so hard to label? Here's where even scientists scratch their heads. Debates still rage. Where does solid end and glassy begin? Is there a sharp transition or just a slow, sneaky fade? The more you zoom in, the blurrier the edge gets, and the less our simple categories work. Let's see it in action. Try to bend glass cold. Snap. It breaks like a brittle solid. Heat it up. Suddenly it flows and stretches like syrup. Only fire lets glass act like a liquid. Room temperature never gets it anywhere close. So what is glass, really? It's an amorphous solid, frozen in chaos, arranged like a liquid, stiff as a solid. Not a slow liquid sneaking down your window, but a material in its own mysterious in-between state. The truth? That weird third state is hiding in plain sight, all around us. Every window and screen is quietly breaking the rules you learned in school. Bust the myth. And if you want more mind-blowing science stories, hit subscribe now.